Okay, so the very center there on our natural numbers, that's what the kindergartners learn to count with. 1, 2, 3, 4, 5, so on. Okay? Then the next ring is the whole numbers. Those natural numbers are whole numbers because they're in that ring, but the only thing additional in that ring is the number 0. See how that works on that? Okay? Might be helpful for you to have some sort of a diagram or a definition if you didn't get one the first time I went over this. The next ring out here is the integers. Natural numbers are in that, whole numbers are in that, but the new thing integers added were those negative numbers. Okay? Then after integers, the next circle has rational numbers, which natural numbers are in, whole numbers are in, integers are in. And what's new in rational numbers is it's numbers that can be written as a fraction. Okay, notice I put 0.75 because that can be written as a fraction, right? Yep. Okay, now in the big square over here in the corner, but not in any of those circles, is irrational because it cannot be written as a fraction. Most famous example is pi. And then if you need more examples, good ones are square roots that are not perfect squares.
So pi, something that's square rooted over something, like over something that's square rooted, is that irrational?
You have to simplify it and check it. So that's what,
Yeah, I don't know how to do that. That's why I just put random stuff down in the first one.
okay, and then all of those are in the big box of real numbers. We're going to learn later in the year about imaginary numbers, but so far we don't know about those, so those are all real. So that one that I wrote over there on the far right, that is actually number 3 on your study guide. It wants us to tell which category negative square root of 256 over 2 will go in. And this is what I was just telling Riley, before we can figure that out, we need to simplify it. So 256 is a perfect square. What's the square root of 256?
26?
No.
16.
16 is right, Austin. So I got negative 16 over 2. And then that will reduce to negative 8. So negative 8 is what we're trying to classify. This is on number 3. Is negative 8 in the very center? Is it a natural number?
So,
No, there are no negatives in the natural circle. Is negative 8 in the whole circle?
nope.
No. Is
Integer.
negative 8 in the integer circle?
No.
Yes, so it's an integer. Is negative 8 in the rational circle? Yes, if you're in the integer circle, you're in the rational circle, right? Is negative 8 in the irrational? No, that one's over there by itself. Is negative 8 in the big box of real? Yes. So for number 3, it would have 3 answers: real, integer, and rational.
We're going over every problem.
No?
Okay, so, like, if it's a number and then pi, would you just multiply, right?
We'll get to that one in a minute. Alright, everybody good on number 3? Let's backtrack to numero uno, number 1. Whoops, I picked the eraser. There we go. I want to keep my chart up there to do number 1 with. Alright, so number 1, you got square root of 3 over the square root of 3. What's anything divided by itself?
1.
1. Okay, so we're just trying to classify 1. Is 1 in the very center in the natural numbers?
Yep.
Yes. And so now we know if we're in that very center, we're in all of these, aren't we?
Yep.
So we are natural, we are whole, we are an integer, we are rational, we are real. The only thing we are not is that one that's not overlapping any of them.
You said natural and what?
Whole, integer, rational, real. You got it, sir, Riley? 1/3. Is that a repeating decimal? Yep, so repeating ones can. Okay, let's talk about number 2 and what Jalen was asking about real quick. The only decimals that cannot be written as a fraction are decimals that go on forever, but they have no pattern or repeat. That's how pi is, 3.14, blah, 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 goes on forever with no pi or repeat. The square root of 3, if you type that on your calculator, it'll go on forever with no repeat. So, but if it has a pattern or if it repeats, you can make that a fraction, like 1/3 is 0.3 repeating. So you can make those repeats a fraction. So on number 2, 5.083 with a bar over the 3, that means that 3's repeating. So you can make that a fraction. Now, if we look at our diagram there, it's not gonna be a natural number, because it's not a kindergarten counting number. It's not a whole number. It's not an
Right.
integer, but we just said it could be a fraction, so it is rational, and it's also
Real.
real. Okay, and on number 4, 2 pi, well, I gave you pi as the most famous example of an irrational. So what if you multiply it by 2? Those digits, 3.14, are still gonna keep going on forever, aren't they? So that one would be 2 pi, would be irrational. But irrationals are still in the big square of real. Your calculator just runs out of space. So if it fills up all the way across the calculator and just stops, if there's not any space left at the end, the deal goes forever. Yes, Summer, ma'am. Real are all of them. Whole, it's just like the counting numbers, 1, 2, 3, but it also has 0 in there. So they can pick up 0. Alright, I wanna hit the properties on 5 through 10. Let me erase this and put that number 3 back up there for the next period class. Negative square root of 256 is negative square root of 256. Flashbacks. Okay, so name the property that justifies each statement. So choices that we're gonna have: associative property, commutative property, distributive property, identity property, and inverse property. Associative property moves the parentheses. So they were around one thing, they move it around somewhere, something else. Commutative property changes the order. Distributive property takes something that's outside and distributes it or multiplies it to everything that's inside. Identity is you get what you started with. Inverse means opposites. Okay, those are just some words that help me remember them, and we wrote those down earlier in the year. So on number 5, you got x cubed over y times 1 equals x cubed over y times 1. So it started with x cubed over y, it ended up with x cubed over y. Which property would that be? Identity. So number 5 would be identity. Now if you wanted to get very, I-D-E-N-T-I-T-Y, if you wanted to get very particular, it's multiplicative identity because it's multiplication that's going on it, right?
Can you give me time to write all these down?
It's up there. Get the right.
What's the first one? Associative?
Uh-huh. Yes, ma'am, and specifically, it's multiplicative identity, but I'll be okay if you put identity. Alright, so looking at number 6, you got 6a squared plus ab equals ab plus 6a squared. What did it do on number 6? Look at it, see what happened on it. Just flip the order, didn't it? So if they just flip the order, number 6 would be the commutative property.
How come it wouldn't be inverse?
Inverse is when you either add the opposite or multiply by the reciprocal.
You know what, give an example.
When we get to one, yes.
Let me see.
Or that's the next problem, number 7. Is identity. Alright, we're ready for 7? 7, we got m times n plus negative m times n equals 0. And this is what Kira was just asking about. So when you're doing the inverse property, if it's addition, think about solving an equation. It's whatever it takes to make it go away on one side. So they added the opposite. So that would be the additive inverse because they made it go away. So inverse on number 7. If it's multiplication inverse, think about solving an equation. Like if it said 9x, you would divide by 9 to make it go away. So that's like the reciprocal. We'll see one of those in a second.
Wait, 6 was identity and complement.
6 was commutative.
Oh,
These will only have one answer. Get 7? Alright, 8. Would you look at 8 and see what you think is going on there? Distributive is right. They got a square root of 7 outside the parentheses. They distribute it to everything in, so number 8's distributive. Yeah, 9 is associative. 9 looks confusing, but if you notice on the left side, it had the 4p times 3 in the parentheses. But on the right side, they changed what was in the parentheses. They took the 3 out, put 5p squared in. When you change what's in the parentheses, it's associative. And then on number 10, nope. Didn't get what you started with. You got 1 over 9s times 9s. So those are reciprocals of each other. When you multiply, they cancel out, so that is inverse. Multiplicative inverse. Alright, then I've marked that we're going to hit both 11 and 12, and then once we get done with those, we'll start skipping around and just picking a few here and there, but not many people remembered about open and close, so we want to hit 11 and 12. Everybody got what you need on your properties? Alright, so on 11 it says answer true or false. If false, give a counter example. Perfect squares are closed under multiplication.
True.
So what that means is if you multiply a perfect square times another perfect square, your answer will still be a perfect square. So closed means it stays the same type of number. So a perfect square, like 4, for example, is a perfect square because that's 2 squared, 2 times 2. So if I did a perfect square times another perfect square, is that answer a perfect square?
Yeah.
Yes, because that's 2 squared, and 4 squared. Okay, number 12 says irrational numbers are closed under division. Okay, what's the most famous irrational number? Pi. So what if I did pi divided by pi? Would my answer be irrational?
It'd be 1.
It'd be 1, because anytime you divide something by itself, it equals 1. Is 1 irrational? No.
It's 1.
So that's, 1 is a rational number, so that's false for number 12, and I just showed my example. They said to give a counter example, I just did. Alright, so then for the rest of this page, 14 and 16 are the two that I marked that would be helpful for us. So just trying to get you some examples of all of it, because we're not gonna have time to do all 40 of them. So we ready for 14? Alright, so I got 4 plus the square root of 121 minus 2 times 3 cubed all over the absolute value of negative 19 minus 2 times negative 8. Now I realize if you're careful and you enter that all in your calculator, you can get the right answer because there's no variables involved. I get that. You're gonna run into a problem though if you do that. You need to realize that this big fraction bar is kind of like a parentheses. So you gotta tell your calculator to do the top separate than the bottom. If not, it's gonna get it wrong. So if you're gonna play it on your calculator, put that everything on top in a parentheses and everything on bottom in a parentheses so it gets it in the right order. Somebody asked me yesterday about, well, will I have to show my work on that on the test? And well, technically no, but if you just write the wrong answer down and that's all, I can't help you any. It's just wrong. But if you wrote the wrong answer and you got several steps right, I might can find you some partial credit. Yes.
Whenever you're doing a test and someone gets like a bad grade, you have to redo it. It's like really
You didn't read all the directions in your Google Classroom. I put that in there. You need to go back and check out Google Classroom. Alright, so I'm going to start showing my steps here. Square root of 121 is 11. 3 cubed is 27. So now this is order of operations. I got to multiply first up there. So I got 4 plus 11. Negative 2 times 27 is negative 54. Now I got addition and subtraction, so I just work left to right. 15 minus 54. What does that give me? 2 negative 29. Negative 39. Negative 39, Austin?
1 second.
Yeah, I put a 3 there, I should have put a 4. Alright, so
Yeah,
I got
39.
negative 39 on my numerator. Now my denominator, see I got multiplication first, so negative 19. Negative 2 times negative 8 is a positive 16. Negative 19 plus 16 is negative 3. Absolute value of negative 3 is 3. So to put them back together now, I've got negative 39 divided by 3, which is negative 13. You got it. Just some good old order of operations. Alright, I'm jumping to 16 now. Are you ready, Freddie? 16. Alright, 16 I got. Do I need to go back? Is that what you said? Okay, well, you stay with us. Come on. Alright. On 16, I've got the square root of, and then inside there, I've got absolute value, the negative x squared minus 4y squared. And they tell me that x is 3 and y is negative 2. Alright, so we gotta plug this in, so I got the square root of the absolute value of it. I'm gonna bring that minus sign down that's in front of the x. And then my x that I'm plugging in is 3, and I need to square it. Minus 4 times my y is negative 2, and I need to square it. Okay? So notice on the beginning that negative is not in with the 3. So you're gonna square the 3 first and then make it a negative. So you're looking at the absolute value of 3 squared is 9, make it a negative. Here on this piece, you do your exponents first, so negative 2 squared is 4. Negative 4 times 4 is negative 16. So now you got negative 9 minus 16, which is negative 25. Absolute value of negative 25 is 5.
That's the absolute.
No, I tried to do 2 steps at once and lost my mind. Absolute value, thank you, Riley, of negative 25 is 25. I was already trying to write the answer and I screwed it up, sorry, Riley. And then the last step, Riley caught me on, square root of 25 is 5. Thank you, sir. That was a silly mistake. Glad you were paying attention. Alright, so I got 17 and 19 marked out of the next 4. Just giving you a sample of everything. I marked both of those work those, yeah. Page to turn. Alright, we ready for 17? Got what we need there? Okie dokie, 17, 3 times 7 minus 9k plus 23k equals 4k minus 24 minus k. Okay, so we're just solving for k here, but we got a lot of cleaning up to do first. So I would just start distributing here. 21 minus 27k, and then bring down that plus 23k. I could go ahead and go to the right side and clean up, but I want to finish cleaning up my left side first. That's just my personal preference. I can combine those like terms. So negative 27k and 23k gives me a negative 4k. All right. Now let's clean up what we can over here on the right side. And y'all been real good about this minus in front of the parentheses, about knowing that means to distribute it. Another way to say it is it means to subtract everything in the parentheses. So if we write that out, that'd be 4k minus 24. And then you got a minus and a minus k, so that would change that to a positive k, right? Then you can combine those like terms. 5k minus 24. Okay, now it's up to you to decide which of those 4 terms you want to start with, and it doesn't matter, there's no wrong answer. They got a preference?
Yeah.
The 24.
Sorry, I heard Austin first, he's gonna add the 24. So that gets me 45 minus 4k equals 5k. Alright, what would we have to do now after Austin did that?
Add 4K.
Add 4k, which that's what I would have did first, but look, we got the same thing. 45 equals 9k. Last step. You got it.
K
Divide
equals
by
5.
9. And k is 5. Whatever, shoot them in. Alrighty, let's jump down to 19. He likes it.
I've always been confused on these.
Well, we're gonna get it figured out. Oh, come on, you can do it. Okay, Riley's correct. It's gonna involve distributing. What I do when I have a fraction equal to a fraction, that's a proportion, and just like in middle school, you solve proportions by cross multiplying. So I'm gonna say 7x minus 3 times 8, which means, in effect, that you're distributing an 8 to both of those, right? And then I'll do the same thing on the other side, 3 times 3x minus 4, which again means I'm distributing a 3 to both of those.
I did this over on the board.
Good job.
For a loading here.
Yeah. So that'll get us 56x minus 24. Yep, equals 9x minus 12. And now you're ready to start solving.
Minus the 9x.
Okay, I'm gonna subtract the 9x from both sides. We're at 47, is that what you said?
47.
Got it. Now what would Riley have to do?
Plus 24.
Yep. And this got you a funny, scary answer. I had a lot of people question this. Because 47x is not something we normally see. So that, you had to divide by 47. And that doesn't simplify. So if you wanted to put it as a decimal, you could, but I'll just leave it as 12 over 47.
You said what? How do we get 12? Oh, I forgot what the negative.
Yep. Alright, I did mark both of those word problems to look at, so that's what we got now. You bet. Let's back up and do 20 first, because that one doesn't get a number answer, so we probably do need to do one of those. Some are good thinking. Alright, let's look at 20. We got SA is equal to 1/2 LP plus B. And wants us to find P. Okay, so we're not gonna get a number answer on this. What we wanna do is take this equation and rewrite it saying P equals. The one we did in class like this was the F and C. We went from Fahrenheit to Celsius. So what we would look at first is to start getting the P all by itself. It's got a B being added. So we're gonna need to subtract that B from both sides. Now, what is SA minus B? I don't know. It's just SA minus B. Okay, now we look at our P, and it's being multiplied by a 1/2 and an L, right? How do you undo multiplication? Divide, so we're gonna divide by a 1/2 and an L on both sides. So over here on the right, I've got the P all by itself now, so I can say P equals SA minus B over 1/2 L. That is so close to being done, but I can't stop there because I got a complex fraction. I have a fraction within a fraction. So I need to get rid of that 1/2, so I gotta think back to about the 4th grade now and remind myself that dividing by a fraction is the same as multiplying by the reciprocal, right? So instead of putting divided by 1/2 on underneath that thing, I can just multiply everything on top by a 2. Because that's the reciprocal of 1/2 over L.
I have a question.
I'm listening.
So it's way off topic, but if I take this class this year, right, I'm in algebra 2 as a sophomore, next year I take 3, then I don't have to do a math class anymore? Since I want to take algebra.
Technically, you wouldn't have to, but I would recommend that if you're planning on going to college.
So I've been thinking about grade school.
That's, yeah, that'd be all right.
Would you still have the answer of does not
You need to do that step. It's not wrong, it's just not finished. You know what? That one we just did? It's, most of the time, Kira, people will get stuck on something like that because you're used to getting a number answer. But you just gotta trust that you're doing the same steps if they were numbers, it just leaves ugly letters instead. We didn't do anything different, we just had, you know, we undid addition with subtraction, we undid multiplication with division, but you just get blah instead of 7. I know that's not a good answer for you, but Alright, let's hit up these couple of word problems. 21, the width of a rectangle is 4 less than 1/2 the length. So if my length is X, the width of it is 4 less than, what did it say? 1/2 the length. Okay, everybody okay with that? So we set that up. The perimeter of the rectangle is 94, find the area. Well, what we know about a rectangle is that if this is X, this has to be X. And if this is 1/2 X minus 4, this one has to be 1/2 X minus 4. So to get the perimeter, you add all those up. So you've got X plus 1/2 X minus 4 plus 1/2 X minus 4. And then it says that that perimeter is equal to 94. I'll write that down in a minute around our room. So combine all your X's. You got 1, 2.5, 3. So you got 3 X's. Then you got a -4 and a -4, so that's a -8. And it says that that is equal to 94.
What about the half?
That's where I got my 3 from, because see, this would be 1X, 2X, 2.5X, 3X, yeah. Okay, so we can solve this for X real quick now. What would you do to solve this for X?
Add the 8.
Add the 8. So you got 3X is 102,
X is 34.
so X is indeed 34.
Yeah, plug it in.
So let's go look at what that means on our rectangle. Our length is 34. So to get our width now, we would have to half that, but 34, which is 17, and then subtract 4, so that'd be 13. Okay, so we've got all that good math, and we still haven't answered the question yet. Question says find the area. So we had to do all that to get the length and width, because area of a rectangle is length times width. 442, is that what you got?
Which?
Oh, so many steps.
Yep. It's kind of a fun one though.
I have a question. You know the new college right there over there, that small school thing?
Mhm.
Is that, do they do
Hey,
like?
Coach, can you hear me?
That history thing?
What'd
Coach,
you say, Austin?
can you come here, please?
I wish I could live with my dad while I was on the
All right, number 22.
Can you come here, Coach?
No, what are you talking about?
How'd you get 13?
Oh, my bad. So we plugged our X was 34, so we plugged that back in. 1/2 times 34,
It's 17.
and then minus 4.
15.
No.
I forgot what I did. I'm sorry.
Gotcha. Alright, going to 22 now. We did one similar to this on a bell ringer one day. It's consecutive numbers, but this one says consecutive odd numbers. So, alright, find 3 consecutive odd numbers such that the sum of 5 times the smaller number and twice the larger number is 33 more than 6 times the median number. You got all that? Alright, so just like we started off, for our first one's X. Our next one, if we're looking for consecutive odds, so let's just give a string of consecutive odds. 3, 5, 7, right? Those are consecutive odd integers. So to get the next one, I would take X and add 2, right?
Oh yeah, the X was 3.
No, it's not plus 3. From 3 to 7, to get the last one, I would add 4, right? Okay, now we gotta put in all that mumbo jumbo that it said. So there's our 3 consecutive odd numbers, such that the sum of 5 times the smaller number, so that would be X, so 5 times the smaller number, sum means we're adding it to something, and twice the larger number, so X plus 4 is our larger number, so twice the larger number. Where was I reading? Is, that's your equal,
It's 33.
33 more than, so you're gonna add that. 6 times the median number, that's the middle number, so 6 times x plus 2.
Then we just gonna go.
Alright, so let's start distributing and cleaning that up. 5x plus 2x plus 8 equals, let's go ahead and clean that up, 5x and 2x, so I got 7x. Okay, over here, 33 plus 6x plus 12. And then I can combine the 30,
Minus 12.
yeah, can combine the 33 and 12, 45.
Because we combine the terms.
Minus 6x.
7,
Alright, so once you get there, you can pick where you wanna start,
minus the 6.
okay? So it gets us x plus 8 equals 45. Subtract your 8. And you got x is 37. So the question says, find all 3 odd numbers. So if my smallest one is 37,
That means that it's gonna be 39 and 40.
no,
39 and 41.
41, there they are.
I added the 43 cent.
Alrighty, I checked 23 before we go to the next page. Do some absolute value equations.
It's 24, that's a different one, right? Because we ever have one like that, it's set.
Yeah, we have, but we'll get it again, hold on. Alright, let's look at 23. Absolute value of -7 minus 9x is equal to 2. So remember the deal with absolute value, that means it's distance from 0 on a number line, which means you can go to the left or to the right, so you gotta write 2 problems. So you get your first problem by dropping the bars and keeping everything like it is. You get your second problem by dropping the bars and making everything on the other side the opposite. Okay, so to start solving these, I need to get rid of a -7. What do I do to get rid of a
Add 7.
Add 7, thank you, sir, talent. So I got -9x is equal to 9, then what?
Divide by -9.
So we got x is -1. Alrighty, so do the same thing over here. You're just gonna have a different number that you're adding it to, so your result will be different. -9x is 5 now. So I'm just gonna leave that as -5/9.
Okay, so it would be, then we would put it in parentheses.
It's when you do inequalities that you've got the different ways of writing it. We haven't got to that yet. Alright, I'll go ahead and look at 24, because y'all were having a couple of questions about that one. I think I marked one like it later, but we'll hit it now. Did everybody get that? I'm sorry. Did I go too fast? Everybody got it? Alright, so I got number 24, absolute value of 5n minus 10 over -2.
I have a question, so.
Alright, so first step in something like this, before you write your 2 problems, is to get rid of the extra stuff. Get rid of the extra junk, isolate the absolute value. So we need to get rid of division of -2. What's the opposite of dividing by -2?
Multiply.
So you got absolute value of 5n minus 10, -15 times -2 is 30.
Next 30.
So now you've got your 2 equations to write, just like before. Keep everything like it is and drop the bars. Keep everything like it is, drop the bars, make everything over there the opposites. Add 10. 5n is 40, divide by 5, and n is 8. Add 10. 5n is -20. divide by 5. And it's -4. Alright, I marked 4 on this page, but I don't know if we're gonna have time to get to all, and then still get to the last page. So let's go ahead and drop down to topic 5, and then if we get done, I'll go back and look at 25 and 26. But I really wanna make sure you got some review notes on all the topics. So let's drop down to, actually, topic 527, we'll do that one. So this is the inequality, Riley, that's what I was talking about, you got the different ways of writing it, so 33x minus 8 times 3x plus 9 is greater than -9. So first thing we would need to do here is distribute that -8, so I have 33x minus 24x minus 72 is greater than -9. Now you can combine those x's. 9x minus 72 is greater than -9. Add 72. No.
63.
9x is greater than 63.
Oh, I thought it was a negative.
Divide by 9. And x is greater than 7. So on the number line, 7, would it be open or colored in?
Open.
Open, shades to the right or left? Right. Good. So then
So,
for the,
7 to positive
very
infinity.
good, Austin, for the interval notation, 7 gets a parentheses to positive infinity. Yeah. We'll get, down there on topic 6, the compound ones where we get more than one, we'll go to number 22 next. Or 32, not at 32. What'd you get?
I got like 12, zeros less than
Which is a true statement, which means what? No solution or all real numbers?
Do you graph that?
Just shake the whole number line.
Okay. Wait, how do you know you got all the numbers?
It's a true statement, it's all real numbers. So Jalen, tell her what the true statement you had was, let me bring.
Zeros less than equal to 12.
So with a false statement, it's no solution, like this said, 0 is greater than 12, that'd be no solution. 32.
So would you, for the interval, you put negative?
Negative infinity to infinity, yep. Okay, so we got compound here on number 32. On the left inequality, there's just one step to solve that, just subtract the 5. So that one's m's greater than 6. Come over here, you got a couple of steps. What would you do here first on the 8 minus 10m?
Minus 8.
Good.
325. So
Negative 10m is greater than or equal to 25. Then what would you have to do? And what happens when you divide by a negative with an inequality? Good, that sign's got to flip, so now it would be m is less than or equal to negative 2.5, 2.5, 5 halves, however you want to write it. So, and a lot of people on the quizzes had questions about fractions or decimals. On the number line, just put it between the two numbers it gives you. So negative 2.5 would go between negative 2 and negative 3. And it would get empty or colored in. Colored in, because it's got a bar, very good. 6 doesn't have a bar, so it stays open. Okay, if I read my m's greater than 6, that means I go find my 6 greater than goes to the right. M's less than or equal to negative 2.5, I go find my negative 2.5, less than goes to the left. Well, you're getting better. Net interval notation, negative infinity to negative 2.5, and it's got a colored in, so it gets a bracket. Good, Austin. Ors are union with. 6 is open, so it gets a parentheses, infinity.
May you explain why it gets a bracket?
If it's the colored in circle, it gets a bracket. If it's the open circle, it gets a parentheses.
We're going over this one.
Taking a test tomorrow.
What?
Been telling you that for a week.
And why do you put a U?
Because there's 2 pieces, and so they have to union together. All right, let's jump down to number 40. Get one out of topic 7. We got plenty of time. They got what you need on that one? All right, so on number 40, I got -3 minus 6, absolute value of 4x, minus 10 is less than -87. Okay, so we got absolute value here, so we know we gotta write 2 equations, or 2 problems, but before we can write 2 problems, we gotta get rid of extra junk. So, lots of people on the quiz tried to start subtracting these numbers out here. No, you gotta get rid of them one at a time. So you're gonna get rid of the -3 first, so you're gonna add 3 to both sides. So that's gonna leave us with -6, absolute value of 4x minus 10 is less than -84. Now that absolute value is being multiplied by -6, so I'm gonna divide by -6. So I got the absolute value of 4x minus 10, I divided by a negative, so I'll flip my sign. -84 divided by -6.
14.
Is positive 14. Now I'm ready to write my 2 problems. Okay, so we're gonna add 10 on both sides. 4x is greater than 24, divide by 4. So x is greater than 6. Add 10 over here. 4x is less than -4. Divide by 4. X is less than -1. Okay, so I'll make my number line up here. -1 will be on the left. 6 will be on the right. They both get open circles. Go find my 6, greater than 6 goes to the right. Go find my -1, less than that goes to the left. Interval notation, negative infinity to -1. Union with 6 to infinity. Alright, you will be able to use notes on your test tomorrow. Study guide can be part of the notes if you wanted to, so hopefully if there's something that you were confused on before, you've got that from today to help you go try to figure it out. You're gonna use the calculator. Here's the deal, they put the pep rally on me after I already had decided we were gonna have the test Friday. Normally, our tests are done that class period, hard and rigid. I'm mean about it, make you finish, so that helps you start getting ready for the ACT. But it's not fair for me to do that to you on a shortened period day. So if we don't get finished tomorrow, I will let us finish it on Tuesday when we come back, only because it's a short period tomorrow. Okay? All right, let's make an A.